So you're going to want to remove the top half, and for the coupler, if you have the helical coupler, there's 2 bolts on the side. You're going to undo those, and then you're going to take the coupler off like this, and when you get here, you can just spin the screw until it comes off all the way. Alright, make sure you put your end stop on the side in a safe place, and if anything, remove your X end stop as well, because that's just going to get in the way. Put that somewhere safe so you remember where it's at. And you may not have M8 rods by 1.25 threads, but I do. So make sure you just get the tap for your lead screws. And my die works with an 11/16 inch socket. So get the socket ready, put it on the side. What you're going to do is by hand try to put a small thread inside the printer, like that. Then you turn your printer on. Just move the Z-axis up and then down. So you see how it's wobbling right now? You want to make sure there's no wobble, so pretty much this is too far forward. Push it back a little bit. Do it again. See how it's straightened out? That's where you want it. I mean, a little bit of slop is okay. You are threading this after all, but you don't want it to be like this. Because if you thread that in there, that's exactly how your lead screw is going to act, and your Z-banding is not going to improve, it's going to get worse. So, if you are patient, I'm now at the bottom of my coupler. Your tap shouldn't move that much. So you see right now how it's only got a slight bit of variation, and that's really not enough to damage anything. This won't cause any Z-banding. As I put my ratchet in reverse, I take this and then I take it out of the coupler. And now about here, pretty much can do it by hand now. And now there's a perfect thread inside this coupler that fits right on top of my stepper motor. But like I said, yours might have 2 cuts instead of the 1, and most of the Robo R1s are going to come with 2, but pretty much this won't go on anyway, but the way that the coupler fits onto it, like this. And so now you can reinstall your lead screw. Just put that back through your X carriage and screw this into here. So when you get back down to the bottom, you can take your pliers, move the pliers this way, grab it with your hand, and then pull this way and push this way at the same time. And it'll grab further into the plastic, making this tighter. What you want to do later on, after you are confirmed that you have no more Z-banding, is take some Loctite, and you're going to want to put it around the threads inside before you put the lead screw back into the coupler. So yes, it takes a little bit of time to get the Z-banding fixed, but if you're patient and you take your time with this, your Z-banding clears up perfectly. This was the first coupler I made. Notice how bad the Z-banding is on it. And this is the second coupler I made. And this was with this one installed. So this coupler was installed, and I made this coupler. Notice, the walls are flat. And on this, the banding is heavy. That's all I did. That is quite literally all it is. It is either your lead screw is bent or your coupler is misaligned. And you have a 3D printer. As long as your 3D printer is printing, although it might be printing with horrible quality Z-bands, as long as it's printing, you can print yourself a new coupler, and as long as you're patient, you can get perfect results on the coupler. The only dilemma with designing your own coupler, and this is one of the benefits, and it's going to be the hardest part, but it's one of the benefits of designing your own model. This model is not going to work on all printers because all printers Z-banding have different diameters. So if you're making a coupler for a 2/10 inch shaft and your Z-banding takes 5/100ths off of each end, it won't fit perfectly onto that coupler. What you need to do is print one out, perfect measurement. Try to put it on. If it doesn't work, don't shove it because you'll break your stepper motor. You'll misalign the magnets. Put it on there. If it doesn't fit on perfectly, go back into your CAD program, expand the hole only. Don't scale the model up because you'll scale the rod out of place. So just go in on the bottom of the coupler. You're going to want to expand the hole for the shaft. After you do that, print it again, try it, see if it works. If it doesn't, do it again. You might have to print 8 before you get it right the first time, but when you finally get it right, you know that it's going to work perfectly, and then of course you have to take your time with the shaft, but your Z-banding is going to go away. And after your Z-banding goes away, and you want to print more couplers that don't have Z-banding in them, well, sadly you're going to have to do the entire process over again, this time going backwards, decreasing the diameter of the shaft, because now your printer has no Z-banding. And the Z-banding isn't going to improve beyond you making the new coupler, whether or not your coupler has Z-banding in it or not. But if you're more careful with how you tap the thread into it and how it sits on the motor, you won't have any problems with your Z-banding. And I sure hope that it helps you with 1, 2, 3D design and helps you fix your Z-banding as well.